Okay, so here we're going to fill in some properties of these shapes. Let's start with the kite. So for a kite, we know that the consecutive sides are congruent, so the ones next to each other are congruent to each other. And one pair of angles are congruent to each other. They're the ones in between the two non-congruent sides. Those are the ones congruent. The diagonals, if you drew those in, are perpendicular, and one of them gets bisected. So like specifically this one in my drawing would get bisected. All right, let's do the trapezoid. With a trapezoid, honestly, there's not a ton that's special about it. It's just that you have one pair of parallel sides, and that's a trapezoid for you. An isosceles trapezoid adds a little bit more, though. In an isosceles trapezoid, you still have the parallel sides here, but you also have a pair of sides that are congruent to each other, right here. These are the legs of the isosceles trapezoid. And just like an isosceles triangle, the base angles are congruent. So like here and here are congruent, which also makes these two angles congruent as well. And these pairs are supplementary because same side interior. And the diagonals, when you draw them in, are the same length. The diagonals are congruent. All right, let's look at the parallelogram. This is the big one. So in a parallelogram, you have the opposite sides are parallel to each other. And I use some color coding because this gets a little messy. The opposite sides are also congruent to each other, as you can see in the red here. The opposite angles are congruent, so like this one and this one, and this one and this one. And the diagonals bisect each other. They split each other in half when you draw them in. All right, now for the rhombus. So in a rhombus, it's kind of exactly like a parallelogram, except these sides aren't different lengths. All the sides are exactly the same. So the opposite sides are still parallel. All the sides are the same as each other. The opposite angles are congruent, just like in a parallelogram. And just like in a parallelogram, the diagonals bisect each other. But added bonus, they're actually perpendicular to each other too, which means there's a right angle that it makes right in the middle there. Okay, let's look at a rectangle. So in a rectangle, hopefully you remember that the opposite sides are congruent and parallel to each other. And the big thing is that all angles are 90 degrees. So all of these are right angles. They're all congruent. And with the diagonals, they bisect each other, just like the parallelogram, and they're congruent to each other, just like we had in the isosceles trapezoid as well. So let's look at the square. The square is basically a mix between, like if you took all the rhombus properties, took all the rectangle properties, and just mashed them together. So with the square, you have the opposite sides parallel. All the sides are congruent. All the angles are congruent, and the diagonals bisect each other, they're congruent to each other, and they're perpendicular. Okay, so in this question, we know that angle C is 65 degrees, and angle CBD is 60 degrees. We're trying to find angle EBD. Now, one thing that's super helpful here is that the consecutive angles on parallelograms add up to 180 degrees. So if you do, real quick, 180 minus 65, you get 115 degrees, which means this whole angle right here has to add up to 115 degrees. Well, we already have 60. So you can just do 115 minus 60, and you get 55 degrees. So that right there is the measure of angle EBD. Cool. And now we have to find the measure of angle BDC right here. Well, since we know that the opposite sides are parallel, that would mean that these two angles are alternate interior angles. And when the lines are parallel, the alternate interior angles are congruent, meaning that that's also 55 degrees.